Hi there, so welcome back to this Python learning journey and welcome back to day 34 out of 100 days of our Python learning journey. So the goal and objective of this learning journey is to cover and master all the Python basics, all the essential knowledge you need to be a Pythonista over the next 100 days. Today is day 34. We're going to continue from where we started on day 31, which is joining data in Python with pandas. So the actual goal of the course is to learn how to merge two or more tables together using the Pandas library. So we've learned all about inner join, left join, right join, outer join. So on today, which is the last little bit of lesson in chapter 2 rather. So we are in chapter 2. So the course called Joining Data in Python contains 4 chapters. We've covered 2 chapters so far. We're on the chapter 2. So we're on the last few lessons of chapter 2, which we are going to be looking at how to merge a table to itself. So all of the other joining types we've covered from day 31. You can catch all of that from day 31, 32, and 33, where we looked at left join, right join, inner join, and full outer join. So they want to learn all about self join. So if I share my screen real quick, so this was what we started on chapter 2 left join, where we look at a bunch of code to actually perform left join. So I just encourage you to go, as we've done joining data with pandas, basics of joining data with pandas, where we looked at in this scenario, we actually looked at our inner join and right join, and definitely left join. I think we started left join on chapter 2 exactly. So we've covered a lot. I'll just go to my DataCamp platform. That is where we are using the platform you're using to master all the necessary Python skills. I just want to make sure the live stream is moving smoothly. So actually use the DataCamp platform. If I just click on continue without any other delay, let's continue with the lesson. So we've covered quite a lot here. You can see we are actually using the pandas library. So the data set we are using here is a pickle file. So all the data sets we'll be using is already linked under the YouTube description. So do make sure to follow the link and have access to all the data sets we used to come up with all this line of code and all these analysis. So we're on chapter 2. This is this Python, this Jupyter notebook file here. So this was what we did yesterday. We did left join, then we also perform an inner join. So just go back to day 31 and 32, you can see. So this was what we covered on day, which is 23 hours ago, day 34. We did a right join. We also did some inner join also. Click on got it. So we just complete these few lessons here, merging a table to itself, which is self join. And you can see that we practice left join, then right join, and other types of join rather. We also did the right join. We solved a couple of challenges here. So we just continue from merging a table to itself, self join, answer a few questions, merging on indexes, index match for movie ratings, and a couple of challenges right there. So without much introduction, we will just continue from there. Okay, let me just put on my headset real quick. I'll probably just switch on my camera this time around.
Hello again. In this lesson, we will talk about merging a table to itself. This type of merge is also referred to as a self join. So, let's get started. When would you ever need to merge a table to itself? The table shown here is called sequels and has 3 columns. It contains a column for movie ID, title, and sequel. The sequel number refers to the movie ID that is a sequel to the original movie. For example, in the second row, the movie is titled Toy Story and has an ID equal to 862. The sequel number for this row is 863. This is the movie ID for Toy Story 2, the sequel to Toy Story. If we continue, 10193 is the movie ID Toy Story 3, which is the sequel to Toy Story 2. If we would like to see a table with the movies and corresponding sequel movie in one row of the table, we will need to merge the table to itself. In the left table, the sequel ID for Toy Story of 863 is matched with 863 in the ID column of the right table. Similarly, Toy Story 2 of the left table is matched with Toy Story 3 in the right table. We will talk more about this later, but the merger is an inner join. Therefore, we do not see Avatar and Titanic because they do not have sequels. To complete this merger, we set the sequels table as input to the merge method for both the left and right tables. We could think of it as merging two copies of the same table. All of the aspects we have reviewed regarding merging two tables still applies here. Therefore, we can merge the tables on different columns. We'll use the left on and right on attributes to match rows where the sequel ID matches the original movie's ID. Finally, setting a suffix argument in a merge method allows us to identify which columns describe the original movie and which describe the sequel. When we look at the results of the merge, the title underscore ORG and title underscore SEQ list the original and sequel movies respectively. Here, we listed the original movie and its sequel in one row. Now that we have our result table from the merger, we could select only the title underscore ORG and title underscore SEQ columns. We can see that we have successfully linked each movie to its sequel. Pausing here is a good time to highlight again that when merging a table to itself, we can use the different types of joins we have already reviewed. Let's take the same merger from earlier, but make it a left join. The how argument is set in a merge method to left from the default inner. Now the resulting table will show all of our original movie info. If the sequel movie exists in the table, it will fill out the rest of the row. If you compare this to our earlier merger, you now see movies like Avatar and Titanic in the result set. You might need to merge a table to itself when working with tables that have a hierarchical relationship, like employee and manager. You might use this on sequential relationships, such as logistic movements. Graph data, such as networks of friends, might also require this technique. All right, let's practice merging a table to itself.
So merging a table to itself is kind of tricky. You have to understand when and how to merge a table to itself. Having a good understanding of the data set is very important. So let's look at self-join. So self-join, merging a table to itself can be useful when you want to compare values in a column to other values in the same column. Okay, a value in a column to other values in the same column. Hmm. In this exercise, you will practice this by creating a table that for each movie will list the movie director and a member of the crew on one row. You will be given a table called crews. Let me see if you have access to crews. Let me check our data set that we have here. I think we do. Great. We have access to the data sets, database or data sets. So I'll be given a table called crews, which has columns ID, job, and name. First, merge the table to itself using the movie ID. Okay, this merge will give you a larger table where for each movie, every job is matched against each other. Then, select only those rows with a director in the left table and avoid having a row where the director's job is listed in both left and right table. So this filtering will remove job combinations that aren't with the directors. Ooh. Okay, let's give it a shot. I'll need to connect to the cruise table has been loaded for you. So I need to load it on my own computer notebook here too. So let's load the Creo movies. I'll just copy this line of code and load Creo movies, Creo data. Creo? I think that's what it's named here. Creos, okay. With an S. Fields. So let's see what the table looks like first. I'll just change this to fields. Let's see. Okay, let's run the code. Great. Hmm. Okay, I need to run all these file back. That is because I have closed them since yesterday. Okay, okay. Where is that? I'm having an error here. Why? Let me just delete this. Now let's try one more time because I used the same line of code to run this and I got my results. So let's see this in action again. We have queries there. I have my data sets here. Okay, just double checking. Okay. Uh-oh. Nobody named Pandas. What? Why am I having an error this time around? Come on. Not today. Let me just go up and copy this. If I run this line of code, I shouldn't get any error. No error. So am I getting error with that? I call on movies now. Well, I have my results. So am I trying to connect to this crew database? And I'm having error here. Why? Why? Let's give it a shot. Okay. Let's see. Let's call it. Ooh. What is error now? Okay. Let me try to troubleshoot this real quick. So I'm trying to troubleshoot the data, the error. I expect an error. Normal. Okay. Okay. Hmm. Interesting. Okay. Problem solved there. So we can just use this to load the pico data. So I was having so we have over 4,000 rows of data for this fields data. Interesting. Just do dot page for this. Just to see the few rows of data. Great. We're able to solve that really fast. So we use another pico pd.read pico, then the file path. So the file path has been is pointed to in my data set here. I'll just change this to this is another method. Loads the queue data. Queue data set. Interesting. So we have it there. So we've imported our libraries, pickles and pandas from above over there. So because I was having that error because the data frame, this queues data, this data rather, is actually loaded, is likely a pandas data frame. This queues data is in a pandas data frame. So I just have to load it with a pandas using pandas data frame format rather than using this pickle.load that we'll be using since all this while. Rather than using this pickle.load, we just use this pickle read.pickle to solve the challenge. So let's go ahead and continue with this one here. So the quiz table has been loaded for you. We say we have to merge the quiz table to itself. So to a variable named self merge. So merge the quiz data. So I want to merge it to itself. So we're going to be quiz self merge quiz table. We're going to be quiz dot merge. So that will be I'm going to be using quiz also. I want to merge it to itself, comma, I want to use an inner join. Since it's an inner join, I'm just going to say on the ID. I want to merge it on this ID. Let me check the common column there. I want to merge it on the ID. If you use quizData.shape, dot shape, this should give us the total number of rows there and the number of columns. Just one, two, three, four. 4 columns. We are looking at over 4,000 rows of data. Okay, so let's continue from there. On the ID column. Now, since it is an inner join, so I'm going to add a suffixes column here just to differentiate the table. Since I'm merging it to itself, so I need to differentiate the columns by suffixes. So dir and queue. So my suffix, I also copy this suffix line of code here. So our suffixes, comma, suffix is going to be dir. So the left one, that is the first row, then the right table. So let's run the code and see. We shouldn't have any error there, but let's see it here in action. So, but this time I'm going to be create data, that's underscore data, then underscore data for this to work. So we shouldn't have any error there. So let's see what we have here. Well, I can see now we now have 7 columns instead of 4 columns. So 4, but we have over 8,000 rows of data. Since we are using an inner join this time around. Let me just do dot edge. You can see the ID departments, job, name, department again. It just goes over and over again. Then I could just do dot edge just to see the few number of rows. So I could do this self merge here. This could do self merge dot shape. Just so that we have over 8,000 rows of data and 7 columns now. So let's submit the results here and see. So we got that. So create a Boolean index name Boolean filter that select rows from the left table with the job of director and avoids rows with the job of director in the right table. Okay. So we said then select only rows with the director in the left table and avoid having a row where the director's job is listed in both left and right tables. So we need to filter and only select for director from the left table, which is this table here. Okay, let's see how to do that. Okay, let me get rid of the head first and see. So we have so we have director here. Okay, director, directing. Okay. We after this job, director. So we only need rows where this job is director. We don't want to rows where there is director in this other the left, the one we join on the left, on the right. So we want director rows to be maintained on the left, while we don't want director to be on the right. Okay, interesting. Let's see how to do that. Okay. So create a Boolean index named Boolean filter, which is created already. That selects rows from the left table with the job director. Okay. Boolean filter Q self merge job director equals to the select rows. So equals to where the job directors this table here, this column here is equal director to director. So we're going to use double quote there. But the job director and avoid rows with job director in the right table. So the right table is this table called job queue. This one here. Yeah. Let's see. Job queue where it is not director. So let's see the code in action. Okay. Let me copy this and see it here. If I run it here, let's see. Great, we don't have any error there. So if I call on this Boolean filter, let's see the results we are going to get. Ooh, so we're having false, true, false, true, false. So it's going to be returning where those rows are true and when those rows are false. Okay, what I could do is, okay, We still have our over 83,000 rows of data as we have here. 834,000 rows of data. Interesting. Okay. Let's submit it here and see. Great, we got it. We got it there. So what we need to do next is to print the first few rows of direct queries. Okay. And that says use the dot add method to print the first few rows of direct queries. Okay, direct queries equals to queries. Let me just copy this here. So I could just avoid this one here. So direct query is going to be queries self-merge the Boolean filter here. So in bracket there. If I run this, you should see it better in a great view. Interesting. I will now have just 4,000 rows of data. Hmm. So let's charge real quick here. So what we just did is to get rid of this job queue from up here and get rid of rows where we have director there. So we only have the queue members here. Interesting. So I'll just do direct queries dot add. So you can see we have just director. So with the director, the department crew, but their job is going to be their main roles, not director showing in both end again. I hope you understand that. So it's not quite easy to explain, but I hope that makes sense to you. Shape. So let's look at the number of rows we have there. Just over 4,000 rows. And initially it was 4,000, 42,000 rows. Interesting. This is over 40,000 rows of data here. Okay. Let's say direct queries. Let's put in the same result here. Dot edge. Voila. You can see we have same results here. Director James Cameron, James Cameron, James Cameron, James Cameron. So we nailed that easily. So great job. So by merging the table to itself, you compare the value of director from the jobs column to the other values from the jobs column. With the output, you can quickly see different movie directors and the people they work with in the same movie. So we don't want to repeat the directors again in this instance here. So we really want to see the people they've worked with, not the director coming in place in two scenarios. That was why the data was filtered to just 4,000 rows of data after the self-merge. So I hope that makes sense. Don't worry, you have access to the data set. You can just have a quick view of what has been done there. So let's solve this exercise. Let me just minimize this back. So select the first statement about merging a table to itself. So you can merge a table to itself with a right join. So you can merge a table to itself with any type of join. Merging a table to itself can allow you to compare values. Merging a table to itself can allow you to compare values in a column to other values in the same column. That is correct. The Pandas module limits you to one merge, where you can merge a table to itself. You cannot repeat this process over and over. That's false. Merging the table to itself is like working with two separate tables. Exactly. So that's false. So the Pandas module limits you to one merge. That's not true. Where you merge the table to itself. So that's totally false. So interesting. So let's see what we want to learn here. Merging on indexes. Okay. And that should be our next lesson. So we just spend just 30 minutes in the live stream. So let's see what we want to learn in this merging indexes. Let's see.
So far, we've only looked at merging two tables together using their columns. In this lesson, we'll discuss how to merge tables using their indexes. Often, data frame indexes are given a unique ID that we can use when merging two tables together. Here, we show the movies table that was introduced earlier in this chapter. The index is the default 0, 1, 2, 3, etc. auto increment. In the second version, the ID column is the index for the table. There are different methods to set the index of a table, but if our data starts off in a CSV file, we can use the index column argument of the read CSV method. This lesson will not focus on how to set a table index, but how to use that index to merge two tables together. Recall our example to merge the movies and tagline tables using the ID column with the left join. Let's recreate that merge using an index which is now the ID for the tables. Our merge statement looks identical to before. However, in this case, we are inputting to the on argument the index name, which is called ID. The merge method automatically adjusts to accept index names or column names. The return table looks as before, except the ID is the index. Let's try a multi-index merge. Here we have two tables with a multi-index that holds the movie ID and cast ID. The first table, named Samuel, has the movie and cast ID for a group of movies that Samuel L. Jackson acted in. The second table, named Cast, has the movie ID and cast ID for a number of movie characters. Let's merge these two tables on a multi-index. In this merge, we pass in a list of multi-index names to the on argument, just like we did when merging on multiple columns. Since this is an inner join, both the movie ID and cast ID must match in each table to be returned in the result. It is interesting to see that Samuel L. Jackson has acted in over 65 movies. That's a lot. There is one more thing regarding merging on indexes. If the index name are different between the two tables that we want to merge, then we can use the left on and right on arguments of the merge method. Let's go back to our movies table shown in the top panel and merge it with our movies to genres table shown in the lower panel. In this merge, since we list the movies table as the left table, we set the left on equal to ID and right on equal to movie ID. Additionally, since we are merging on indexes, we need to set the left index and right index to true. These arguments take only true or false. Whenever we are using left on or right on arguments with an index, we need to set the respective left on and right on index arguments to true. The left index and right index tell the merge method to use the separate indexes. Now it's time for you to try out a few exercises.
Okay, so let's see index merge for movie ratings. So those are the last two challenge here. Index merge for movie ratings. So let's see that in action. So to practice merging on index, you will merge movies on a table called ratings that holds info about movie ratings. So ensure that you merge returns all rows from the movies table. Definitely that's the left join. And only matching rows from the ratings table. That is the left join. So since we want to return all rows from the movies table, our movies table is going to be our left table, and our ratings table is going to be our right table. The movies and ratings tables have been loaded for you. Let me quickly check if I have access to those movies and ratings. Okay, I have movies table here. Ratings. Great. I have access to both movies and ratings here. Let me try to load them up in my Jupyter notebook here. Hopefully, I can still use my old. Okay, let me use this new method to load them. I want to load the movies table. Load movies table. Movies data sets, which is movies here. Let's change this to movies. Movies with an X. Yep. And I call it movies. Great. Successful. Let's see where we are there. Because we are just over a 4,000 800 rows of data. Let's do dot add to see just a few rows. We have the movie ID, the title of the movie, the popularity and the release dates. Let me load the ratings data sets. Rating. Let's load the ratings data sets. Ratings with the spelling of ratings. Ratings. Just include double S there. Okay. Movies ratings. We could call this ratings data sets. Oh, I call this movies. So you have same thing here. Ratings, grades. Ratings.l. So we have our rating. We have the ID, vote range, and vote count. Definitely the ID of the movie. You can see that here. Definitely. So that will be our common column to merge on. So let's continue from here. So it says merge movies and ratings table on the ID column, keeping all rows from the movies table and save the result as movie ratings. Okay, let's do that. That should be movies dot merge. So once we merge that to the ratings table on the ID column, which is the common column there, ID column. We want to use the R method, which is left join. Since we want everything from the movies table, we don't need to put any suffixes. So let me just copy this and give it a short. Let me just copy all of this right here. So let me just do one more thing. Let's say movies data dot shape to see what we are dealing with. Just write 4,800 rows of data. What about this? Ratings. Hold on a minute there. Okay, sorry about that. I'm back. Just a call came in. Okay. So we are looking at ratings data dot shape. Oops. Ratings. Let's spell that okay. Oh, sorry about that. So ratings underscore data. What am I missing here? I need to put that exactly. So we have both data set, just 4,800, 4,800. So if I use this to merge the two data together, movies is not, oh, exactly. So mine is movies data here, and this is underscore ratings data here. Let's do that again. Voila. So let's look at movies dot rating. Since we want to return everything from the left table from movies, and only matching records from the right table. So let's see it in action. Let's see. You can see we have exactly 4803. Same thing we have here, 4803. That means the data set there match completely. Okay, interesting. You can see. So let us do dot head just to see few rows. You can see. So I could just do movie ratings dot shape. So you can see we have just that we have now 6 rows of data rather than 3 rows of data since we've matched 2 tables together. So I'll just continue from here. So now let's go back to this challenge here. So let's run the code here as we have similar results here, and let's submit this. Good work. So merging on indexes is just like merging on columns. So if you need to merge based on index, there's no need to turn the index into a column first. Interesting. You do actually merge on indexes here. This is the normal index that is being referred to right here. These indexes. So I guess we didn't actually merge on index. We actually merge on this ID column here. So let's continue. Oh, good. Ignore this. I've been learning for this. Pick a streak. Pick a streak goal. I'm always committed. So I've been learning offline over the last. Let me just do 50 days. You know, we could go 50 days. We could go 50 days just learning. We could do it. So that's by the way though. So let's solve this last challenge. And this is the last and only challenge here for this chapter 2, rather. So we've covered a lot so far. So let's see what we have to do here. 1, 2, 3, 4. Wow. Let's see. So do sequels and more. So it is time to put together many of the aspects that you have learned in this chapter. Interesting. Let me see what we need to do that. So we can actually do that in 15 minutes. So let's solve this challenge. So it is time to put together many of the aspects that you have learned in this chapter. In this exercise, you will find out which movie sequels earn the most compared to the original movie. To answer this question, you will merge a modified version of sequels and financials. Oh, let me check if I have access to those data sets. Oh, oh, great. I have sequels and financials. I have. So let's solve this last challenge here. So to answer this question, you will merge a modified version of sequels and financials tables where their index is the movie ID. Great. You will need to choose a merge type that will return all of the rows from the sequels table and not all the rows from the financials. That's basically a left join. If the sequels is going to be our left table, need to be included in the result. So from there, you will join the resulting table to itself. Ooh, so that you can compare the revenue values of the original movie to the sequel. Next, we calculate the difference between the two revenues and sort the results in data. Okay, so let's give this a shot. Let's see this. We have sequels first. We have it here. I'll just load the sequels data. So let's load the sequels data for this challenge. Sequels data sets. As you can see, it is spelled Sequels. Sequels. We know this. Okay. Okay. Let's see what we have here. Great. No errors there. Let's see the results. Cool. We have just 4,800 rows of data. So let's do dot head. You can just see few rows of the data sets. We have the ID, title, and the SQL number. Why some are missing? So SQL.shape. That is just 4,800 rows and 3 columns. So the next data is the financials data. Load the financials data. Let's see. Financials. Okay. Financials data sets. So financials data sets. So let's load this financials data sets. So let's see what we have here. We have just 3,000 rows of data for financials. Really showing the ID, the budget, and revenue for that movie. Exactly. So let's do financials dot head and see. So dot shape. So you can see the number of rows that we have here. Interesting. So let's go back to the question. So we need to match the two tables together. So with sequels table on the left, interesting. Sequels financials. Sequels table on the left. Dot merge and merge it to the financials. So we want to merge that to financials. Financials table on an index, on the index named ID. So the index named ID is this. Okay, named ID is that. Let's see. Command that should be on the joining clause ID. Ensure that all rows from the sequels are returned and some rows from the other table may not be returned. So on ID, so our how is going to be left join. That is the left join. So that's quite straightforward there. Let's copy this. Let's on the code here. So ours is going to be sequels underscore data, while financials is underscore data. Oh, financials data. Oh, so you can see, spell that wrongly. And did we nailed it. So we're going to have sequels financials just above 4,800. Same result we have here. 4803. 4803 and 5 columns. Let's do dot head. Then you can do sequels fin dot shape. Just need to know the number of rows I'm working with. So definitely we nailed that here. Let's submit. That's first step. So merge the sequels fin table to itself with an inner join, where the left and right tables merge on sequel and ID, respectively, with suffixes equal to org. That should be financial and STQ, saving to this data frame here. So let's give that a shot. So I want to merge this sequels financials to itself. SQL financials to itself. Want to merge it to SQL financials also. How? With an inner join. With an inner join where the left, okay, with an inner join. So even though we don't need to specify the join type, and that should still work. Okay, so left on, it says where the left and right table merge on SQL and ID. Let's check the table first. Okay, it's going to merge on SQL and ID. Okay, okay, hold up. So merge the SQL's financial table to itself with an inner join where the left and right tables merge on SQL. The left table that should be on SQL. Okay, interesting. On SQL. So let's do that on the SQL column. And right merge on. Right will merge on the ID. On the ID over there. Okay, on ID. So we need to mention the right index. This request here. So the suffix, let me just add the suffixes first. I can think about the right index, this line of code after that. What is that right index though? So I'm missing this right index. Let me just run the code. I'm going to need a help there. Let me see the help. And I can just ask for help there. Right index should be the right on the ID. Which ID initially? Okay. Right index should not be Fox. So what's the issue? The error message indicate that there is a name error because a placeholder is not defined. You cannot use, okay, let's use the right index to be false first. Since we are not merging on the right index there. False. Now let's run the code. Okay, let me give it a shot here. Let's give this a shot here. So this is going to be SQL's financials. Oops. I need to plug my laptop real quick so I can complete this challenge. I'm trying to save power. That's the reason why there. So that's correct. So let's run this original SQL's financials and see what we have here. Wow, we now have just 90 records. Interesting. Let me do dot add, and I could do just 4 rows of data with a lot of information. I could do dot shape. So we just have 90 rows of data and 10 columns for this challenge. Let's see if we nailed it in the, let's submit the code. Oh, great, we got that. Nope, we didn't. There's an error somewhere. So check your call. Did you correctly specify the argument right index supposed to be true but got false? Oh, this is supposed to be true. I'll have to look at that lesson again and see. Oh, great, we got it now. So this is supposed to be true rather than false. I saw the instructor mentioning it in the lesson right there. Okay, now let's see. This is what we have now. Now let me run the shape again. I now have 39 records. That means false is wrong there. So the reason why we need to use right index false, I'll just watch the tutorial one more time to troubleshoot that. Now select the title, organization, title, SQ, and different columns of original skill and save it as title difference. We need to select starting column. To do that, we just mention the column. It's pretty straightforward. Just mention the column we want to select. We need to select few number of columns in this instance. I'll just copy this. So add calculation to subtract revenue from organization. Okay, that has been added. Select the title. Oh, okay, let's look at this calculation first. So a new column was actually added to this calculation. Let's see. Hmm. A new column was added. So probably I need to add it in this instance here. Now let me now call on this table then. Let's call on this table back. You can see that a new column, we have how many columns here? Just 11 columns. So if I call on it back now, we should have 12 columns. That's now we have 12 columns. So the calculation was added. We just added a different column, which is revenue minus revenue from here. Okay, now interesting. Now let's select the starting number of columns. Select the title, organization. Select this column. Select this column, comma, this column, and this new column. Ooh, what is the error there? Okay. Oh, I need to use double quotes there for this to work efficiently. Interesting. So if I select this now to troubleshoot this, so since I want to select starting column, I need to wrap it in double quotes. So those starting column can now be called upon. And so we selected just these three columns. This title org, title sec, and the difference, the calculation, which is just, let me just say dot shape here, dot shape, nope, I mean dot head rather, dot head, because it just few rows of data. Then if you look at the dot shape of that record, that should be just 39 records out of 30. Let's see, this is 39 record now exactly, so 39 record and 3 columns. If I go back here and submit the code, now sort by title differential sort this title differential by different in descending order to print the first few rows. Okay, we need to sort. So title dot sort, we just sort this to see the results. The challenge is quite intense. Let's run the code. Uh-oh. Hmm. Does it have to be in brackets? It doesn't have to be. Okay, what's the error? Let's get up on the error. Oh, okay, I want to sort this. Oh, my mistake was I didn't pay attention. Sort this title differential by this column. Yeah, that column in descending order. So I need to sort by comma in descending order. So if you are ascending would be equal to false. So let's see, is that what was here? Exactly. False. If I run the code now, we shouldn't have any error. Interesting. Now let's see it in action here. I'll just get rid of this print and run the result now. So you can see that we have before sunrise, the Amazing Spider-Man as with the highest revenue here, followed by Star Trek 3, followed by Indiana Jones, also and the Terminator. Interesting. There's a lot of analysis in less than 15 minutes. Let's submit the code. So amazing. That was great work. So to complete this exercise, you needed to merge tables on their index and merge another table to itself. So after the calculations were added and sub-select specific columns, the data was sorted. You found out that Jurassic World had one of the highest. Oh, hold up. I have Jurassic World here. Then what do I have here? I have Amazing Spider-Man. Oops, there's an error in my code somewhere. Whoa, 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 what's the error? I got same results from onsets. I'm having a different result here. Oh, so you found out that Jurassic World had one of the highest overall improvements in revenue compared to the original movie. Ooh, Jurassic World 3. That should be Jurassic World 3. Hmm. I'm having a different result here. Interesting. That's not fair. I did this perfectly well, but I was using same code in both scenario. Then why am I having different error here? Oh, I feel like crying, but I won't cry. We just go again. So we are on track. This is just an hour, over an hour, slightly over an hour live streaming. Trying to solve the Python challenge. So interesting. We completed chapter 2, merging tables with different join types. Interesting. So we are moving to chapter 3 next, which is filtering joins. Interesting. Oh, that's a lot. So that'll be the end of the live stream for today. So in this chapter 2, we learned all about merging tables from different sources and definitely merging table to itself in Python. And that has been quite interesting. You can see I was running into an error here and there, but you just have to be patient, look deeper in the code and try to troubleshoot it. Thanks to ChatGPT though. I'll be trying DeepSeek very soon also to troubleshoot some bunch of code when you run into an error. They're quite easy and interesting to use. That's why. All right, I'll see you on day 34 live stream, which no, day 35 rather. I kind of lost track counting, but that's the end goal. Showing up consistently. Do make sure to click on those files under the YouTube description so you can practice yourself also and get your hand dirty. That's one of the best ways to learn. Doing over and over again. I'll see you in the next video on the channel. Remember to give this video, this live stream a thumbs up, hit that subscribe button, and put on the notification bell so you'll be the first to know whenever I come live to learn my Python. I hope to see you all the way to day 100. I'll see you tomorrow. Have a wonderful rest of the day.